To solve an equation with a variable underneath the radical, we're going to isolate that radical and then square both sides or cube both sides or fourth both sides. That's our general approach. Sometimes it may be a little bit more complicated where we have multiple radicals and we have to square multiple times, but that's the general idea. Is isolate the radical, square or cube or raise both sides to whatever exponent you need. So for example, on the one that we see in front of us here, the radical's isolated, it's a fourth root, so I would just raise both sides to the fourth power in order to clear that radical to be able to get the variable out from underneath it. Now, a lot of radical equations have what are called extraneous solutions, meaning that they have answers that you seemingly get by doing everything correctly, but when you plug it back into the equation, it doesn't work. And so there are certain things that lead us to these extraneous answers. One of those is if when you isolate an even root, so a square root or a fourth root or a sixth root of something, and it equals a negative number on the other side. So it's always worth it for us to pause and reflect on what does the root equal when you're solving, because if you have an even root of something that equals a negative, then that's an indication that that problem is going to have no solution, because an even root always has to equal a positive. On the other hand, for odd roots, if it was a cube root problem or a fifth root problem or something like that, those will never have extraneous solutions, because an odd root could equal a negative or a positive depending on what number was underneath that root. So let's put that into practice with the examples that we see in front of us. So in the first one, we see it's a square root problem, and the square root is already isolated. We don't have to do any work to isolate the square root. So we see that the square root is equal to a positive number, so it looks like we should be in good shape to get an answer that works on this one. So in order to solve, I'm going to need to get rid of the square root, so I'm going to have to square both sides of this problem. That's the only way I'm going to get the x out from underneath that square root symbol. So on the left-hand side, the square root and the square cancel each other out, so we just have 2x plus 6. On the other side, we have to square that 4, so 4 squared we know is 4 times 4, so that's 16. And so now we just have a pretty ordinary equation. We're going to subtract 6 from both sides, so we get 2x equals 10. We can then then we can divide both sides by 2, and so we get x equals 5. And so now if we go back and plug that number into our original equation, 2 times 5 is 10, 10 plus 6 is 16, the square root of 16 is 4, so therefore we see that this answer is valid. For the second example, we can see that it's a cube root rather than a square root, so I'm eventually going to have to cube both sides of the problem, but I can't do that yet. I first have to isolate that cube root, which means I'm going to have to add 2 to both sides so that I've gotten rid of everything except for the cube root from this left-hand side of the problem. So I've got the cube root of negative x plus 5 equals 2, and so now at this point I'm ready to cube both sides of the problem. So I'm going to go ahead and do that. So the cube root and the cube cancel each other out, so we end up with negative x plus 5 equals 2 to the third power, which is 2 times 2 times 2, which is 8, not 6. And so now I just have to solve for x, similar to what we did before. So I'm going to subtract 5 from both sides, so that leaves me with negative x equals 8 minus 5 is 3. So again, think of this as like negative 1 times x, so I need to divide both sides by negative 1, and so we get x equals negative 3. And so we can go ahead and double check to make sure that that answer works. If I plug negative 3 in for x right here, negative 3 becomes 3. 3 plus 5 is 8. The cube root of 8 is indeed 2. And then 2 minus this 2 right here does give me 0. So again, we've confirmed that this problem works. The solution we got works. Our next example is another cube root problem, and again I need to isolate that cube root by subtracting 3 from both sides. So that leaves me with the cube root of 12 minus x equals negative 3. Now at this point, I see that it's a cube root equals a negative, but if you'll recall, a cube root can equal a negative or it can equal a positive. It doesn't matter. We're going to be just fine with whatever our result is. It's only on the even roots, like square roots and that sort of thing, that we have to worry about it equaling a negative when we isolate that radical. So I'm going to go ahead and cube both sides. So the cube root and the cube cancel each other out. So I have 12 minus x equals, now on the other side, it's negative 3 times negative 3 times negative 3. So negative times negative times negative equals a negative. And then 3 times 3 times 3 gives us 27. So we have negative 27 over there on that side. So now I'm going to work on getting that x by itself. So I subtract 12 from both sides. So now I've got negative x equals, so negative 27 minus 12, so negative 27 plus negative 12 gives me negative 39. And so then, same as before, if we divide both sides by negative 1, we get x equals 39. And so we can go back and plug this in to verify that it works. But since we know that there's no risk of extraneous answers, if we're confident that we've taken all the correct steps to get to our solution, with the odd root problems, we can avoid having to check our answer if we're feeling a little lazy, like I am here. For the last one here of the set, so this time I've got to isolate the radical, so I'm going to subtract 7 from both sides. So that leaves me with square root of x minus 8 equals negative 7. And so at this point, if I'm paying close attention, I can go ahead and stop and say that this problem is going to have no solution. And the reason is I've got the square root, which is an even root, is equal to a negative answer. And so as long as that's the case, the answer that I'm going to end up with, if I keep on going, is going to turn out to be extraneous. I'm going to go ahead and demonstrate that, but if you catch yourself at this point seeing that you have a root equal to a square root or a fourth root or a sixth root equal to a negative, you can stop right there and automatically put no solution. But let's see what happens if we didn't stop there. So right now I would square both sides. So I'd square both sides of the problem. So the square root and the square would cancel each other out. I get x minus 8. On the other side, I have negative 7 times negative 7. So negative times negative is a positive. 7 times 7 is 49. And so then my last step would be to add 8 to both sides. And so I get x equals 49 plus 8 is 57. So at this point, it doesn't really seem like we've done anything wrong. But if I go back to the original problem now and plug in this 57, so I get x minus 8. So 57 minus 8 is 49. The square root of 49 is 7. But then I have 7 plus 7 is supposed to equal 0. So this is the indication that the answer doesn't work. And so as long as we check our work, we'll still catch an extraneous answer. But we could have stopped here before we even squared both sides. If we recognize that we have an even root that equals a negative, then it's guaranteed that whatever answer we end up with is not going to work if we plug it back into our original equation. So this problem, however you get there, has no solution.